Hey guys, so last week we did day 3 notes quadratic formula, and we plugged our a, b, and c into the quadratic formula, and we got decimal answers because at this point what was under the square root was not a perfect square, so it ended up with a decimal. And then you did the plus and the minus. 7 squared is 72. That does not come out as a perfect square, so it's a decimal. And there you go. This one we had a negative under the square root. You cannot have a negative under the square root, so you had no x-intercepts or non-real answers. But then we learned how to simplify radicals. So within our quadratic formula, that's all you're going to do is start to simplify. So the first problem, you pick out your a, your b, and your c. And then you plug that into the quadratic formula. X equals opposite b plus or minus the square root b squared minus 4ac all over 2a. Okay, just like last week, that was the first step, is to plug it into the formula. Again, be careful here. If the b value is negative, it's the opposite of a negative, so that'll end up being positive. Same thing here. If your b value is negative, you have to make sure that you're doing a negative times a negative, so that part will end up being positive. This is where some people were messing up. Be careful. It's a negative times a negative. That'll end up being positive. So you go ahead and simplify underneath there. And that's 16 plus, oh goodness, I don't have a calculator with me. 8 times 3 is 24. 24 times 4, 96. All over 2 times 3, which is 6. So negative 4 plus or minus 96, 106, 112. And nothing is different so far, except when we reach this point, I have a square root of 112. So instead of taking that square root, typing in the calculator, and getting a decimal, what you're going to do is simplify the radical like we did before. The square root of 112. And a lot of times I'll kind of go off to the side of my paper or down at the bottom of my paper, and I'll take that square root of 112, and I'll do what I did, which is the factor tree. And then the square root of 12 is 2 times 2 times 2 times 2 times 7. I'll type that back in the calculator just to double check. And then a pair of 2s, that'll come out as a single 2, that'll come out as a single 2, and the 7 stays home. So this ends up being for radical 7. So I will go back up here, and I will do negative 4 plus or minus 4 radical 7 over 6. You just replace that square root with the radical version. And then does this simplify? Because we don't want decimals anymore. The first part said decimals. Yeah, go ahead. You type that in, you type it in your calculator, and you get the exact places where it crosses the x-axis. But this one, they don't want that. They want it in simplified radical form. Simplified radical form just means I took my radical and I simplified it. However, one last step is that you cannot have any of these coefficients, any of these numbers that are outside the square root, you can't have them having a GCF. If they do, you have to take that GCF out, just the numbers outside the radical. So 4, 4, and 6, they all have a 2 that can come out of it. So my final answer is negative 2 plus or minus 2 radical 7 over 3. Took a 2 out of there, took a 2 out of there, took a 2 out of there. If you think about it, 4/6 simplifies to 2/3. 4/6 simplifies to 2/3. Let's try the next one in our notes. The value is, the quadratic is not equal to 0, so you have to take that value and move it over. So I'm going to add 5 to both sides. And my new equation, 2x squared minus 6x plus 5 equals 0. You pick out the a, you pick out the b, you pick out the c. And then you plug them into the quadratic formula. X equals opposite b plus or minus the square root b squared minus 4ac all over 2a. Now I'd like you to memorize the quadratic formula, and as I'm doing it, you'll hear me kind of sing-songing it. I'm gonna post a video of how I remember how to sing the quadratic formula, or memorize what it was, through song. You always remember the things through song. So watch the video that I'll also post, and you'll see the Pop Goes the Weasel quadratic formula song. Anyway, here we go. Simplify. 6 plus or minus 36 minus 40 all over 4 underneath the square root. Uh-oh, that's negative. Negative 4 all over 4. So that one has no solution because you cannot have a negative under the square root. So you write no x-intercepts or no real solution. Now what does the word real mean? Well, there is an imaginary solution, which is imaginary numbers, which you'll get to in a later class. But you can write no x-intercepts or no real solution because there's no value. If you try to type square root of 4 in your calculator, it would say no real answer. Next one, I have this in quadratic formula is equal to 0, so I'm ready to pick out the A, pick out the B, pick out the C, and then go ahead and plug it in. X equals opposite B plus or minus the square root B squared minus 4AC all over 2A. And simplify. 7, 49 minus 40 and 2 underneath the square root is 7 plus or minus 9 over 2. Wait a minute, 9 is a perfect square. So 9 just comes straight out as 3. Now since there are no square roots here, I don't have to write it in simplest radical form because the radical is gone. So I go ahead and do what I did above, and I find my two whole number answers. So 7 plus 3 over 2, 7 minus 3 over 2, 7, 8, 9, 10 divided by 2, that's 5. And 7 minus 3 is 4, 4 divided by 2 is 2. So those are my two solutions, and I would probably go to Desmos, type that in, and make sure those are the two x-intercepts. So we had 3 different solutions here. We had whole number solutions, you just write them as the two whole number answers. We had an imaginary value because there was a negative under the root, so no x-intercepts. And then the third situation is where I had a square root that was irrational, so I wrote it as simplified form and then made sure that all 3 of these do not have a GCF. And this is simplest radical form. So we had decimal form up here, simplest radical form, and whole number answers.